In this section, we'll finally tie it all together and start consuming our data store that we wrote last section. First things first, let's tidy up our workspace a little bit. We're probably done with users test here, and let's move users over here as well. I like to have the code that I'm consuming next to the code that I'm writing. It helps me to keep things straight. You'll notice that our user data and our user structs both have some different fields. In this case, we probably want to expose the same data to the API, so let's go ahead and make the match for now. For email, we'll let the user manager worry about validation and what kind of type to store. For us to present it to our users, let's just use a string. Unsurprisingly, that'll break handle.json where we use this struct, but we can fix that very easily. We'll also need to go fix our test. Let's change our property name here. And here. Let's make sure everything passes still. And we're good. Let's minimize this. With that done, let's go back up to the top. We need to talk about the trailing slashes. You might have noticed that when I wrote this path, I didn't include a trailing slash, but I have for most of these other ones. Why is that? Go, when it's routing, will match as much of the string as it can. And if there's a trailing slash with no child configured, it will redirect to the hello endpoint. We can actually prove this to ourselves if we run our server and bring up our API testing tool. Note here that there's no trailing slash. We get hello user. Let's add a trailing slash. We still get hello user. Let's add extra things to the path. We still get hello user. I've done this to make it harder to mess this part up and end up with a confusing error. Unfortunately, when redirecting a post request with a body, the body will not get passed, so our path must be JSON. But because this is a very simple endpoint, just to illustrate handling JSON data, I'm not too worried about it for now. The other thing that we need to be careful of is that if you notice right now, this is set to get, and we're still getting a response. This isn't really correct, and it should be a post, but we also get a response there. There's a couple different ways to handle this, and we'll talk about a couple more of them later, but while we're talking about the route, let's just add post here. This is a relatively new addition to the Go router functionality, and it will limit the HTTP request method to what we type here. If we do this and restart the server, you can see that post still works, but if we go back to get, we see method not allowed automatically. We'll examine a couple other ways to handle this momentarily, but I wanted to talk about this while we're here. Next, let's start getting set up to use our users manager here. You'll notice that our new manager function returns a pointer to a manager. That's because we want a single instance to be consumed by our API. Because the data goes into that instance, we need to be able to retrieve the same data. There's a couple of different ways to do this, and this would be very much the same if it was a database or a client for a different service. It is considered generally acceptable to use a global variable for this purpose, but I usually prefer to use a struct that represents the server. So let's go to the top, and we'll do the setup here. We'll do it here because if new manager was able to return an error, because it was a database, for example, and it was unable to connect, let's say, we'd want to know and either panic or engage retry logic here before we start the server, because we can't run without this connection. Next, we'll need to know what exactly our struct is that represents our server. Let's just create a new one that's called server. For now, server will only have a pointer to a user's manager. Now let's create an instance of a new server. And use that manager. Let's also go ahead and stop our server. There's a couple of different ways that we could wire this up. For example, and you don't need to type this if you don't want to, but just follow along and see. And let's just say we'll use the user endpoint for this example. We could use a closure here. In this case, the signature of our hypothetical server would take the manager object as well. It would look like this. Let's delete that since we don't actually want to use it. And this as well. The other thing that we could do is we could do a handler instead of a handle func. Again, you don't need to type this, but just follow along. In this case, we'll use the user path again. But here we're going to provide a function call instead of just a function. And we'll pass it the manager. In order to use this, we would come down here and we would write a function like this. A handler returns a function that would handle. And in this case, we'd use the manager. This is more like a callback. I find this to be harder to read, so let's go ahead and get rid of that as well. The other thing that we could do is we could add multiple handlers to this same endpoint using a closure with a switch on the method. That would look like this. And again, you don't need to type this, but just follow along. Again, we'll use the user route. And here we'd switch on r.method. This is available within the request. We can add a case for, let's say, post. And we'll say that we would call example add user again. We would also want to do a case, let's say, for get. And we would handle get in some way, shape, or form. Lastly, we would do a default. Here, let's use the HTTP status text function to return the status text for the status method not allowed. And the same for the code. I actually prefer this style if we're going to have multiple different methods that are accepted by this endpoint, because it makes it very clear what exactly the cases are that are going to be executed. The other option is just to make different endpoints for your add and your get. We'll do that going forward just because it's easier. We won't need this, so let's go ahead and delete it. So, what method do I prefer? Let's write the add user function. In this case, we'll use a method. The signature will look a lot like what we've used before. We'll just hang it off of a server object. This is why I prefer having a struct. For now, let's go ahead and set up our temporary error as we normally do. And let's go ahead and register it with the mux. For this, let's say we want to restrict this to post. And we'll put it on the add user path. And then we can just add our new method like we have before. Now that we've wired that up, let's go ahead and add a test. We'll call it test add user. Here, we'll create a test user object like we have before. And we'll marshal this object into our request body, just like we did with the JSON test. Also like before, it'll be a fatal error if for some reason we fail to marshal. Now let's create our request, just like we did before, using a bytes.new buffer for the marshaled request body. Note that we're using method post here. As usual, we need a new HTTP test recorder. However, unlike before, we need a test manager, and also we need a test server. Now, we call our method just like we did before, but we'll use the test server object we just created. And we'll do the same validation with the desired status code. Now we need to test the body. Because we have a user manager here, and we know we can get a user by name, it's easy for us to test that. Here, if for some reason we have an error, it'll be fatal to the test as well. Now we need to compare. We have a result user, but remember, this returns a pointer to a users.user. This is a user data, because that's what our API ingests. So you can see here, we might already want to have something that can easily convert these. Let's go ahead and write one. Over here, I like to keep internal packages at the bottom. You can organize this as you see fit. Let's just call it convert user to user data. It's going to take a user, which is a pointer to a users.user, because that's what we get. And it's going to return a pointer to a user data. There's no particular need to use pointers here, but because we get a pointer back, which we did because we wanted to be able to nil check it, it's easier just to use a pointer here. And if it takes a pointer, I find it helpful to return a pointer as well if there's no compelling reason not to, just to keep things all the same. Here, for now, let's return nil, just so that we can compile. And let's also comment this out, because we're going to write a test first for this. Let's call it test convert user to user data. Here, let's set up some variables to hold our parameters like we have before. Once again, we'll parse the email and consider it a fatal error if we fail to parse for some reason. Now, let's create our test user. This is a users.user, because that's what we convert from in this function. And don't forget to dereference the email. Now, let's do the conversion. And don't forget to pass this a pointer. Now let's create an expected user that we can compare with. And note that we'll use address of here. And we'll use the string of the email. Now, let's use deep equal to compare them. And we'll output a meaningful error with line breaks like we have before. Let's go ahead and run this. We expect it to fail. And as you can see, we wanted this, but we got nothing. It's nil, as we expect. But there is something interesting here. You'll note that the string of an email includes the little angle brackets here. We may or may not want that in our output. I think it looks better without. So let's go ahead and adjust our test here. Instead of string, let's use address. Let's run this again. I like the look of this a lot better. We'll need to account for this when we do our conversion as well. It's a good thing we checked. Because this is a very simple conversion, and we're not doing a lot of information hiding or combining or anything like that, let's just create a new user data object. And here, we can actually just directly pull all the information from user. And we'll use address here as well. Then we return a pointer to converted. Now let's run our test again. And it passes. Now that we have this, we can use it. Let's go ahead and tidy this up real quick. And uncomment this. Here, let's use our new conversion. And then we can deep equal them. Make sure to use a pointer to a test user here, because converted result also returns a pointer. And if one is a pointer and one is not, they are not deeply equal. Here, we'll once again build our error string. Now, we can run the whole set of tests. And as you can see, our new one fails. Most importantly, it fails as we expected. We got a bad response code, which is not a fatal error, but we did get an error getting the test user back out of the manager. No results found. That makes sense because we didn't add anything to the manager. Let's go ahead and write that code now. Normally, I like to keep methods closer to the top, which is where the struct is usually defined, but this is just visual organization, and you can do as you see fit here. Let's get rid of our temporary error. Because this endpoint is going to take data from the user and end up modifying our system, let's be more strict about what we accept. First, we're going to use a different way to read the body. We're going to use HTTP max bytes reader, like so. You'll note that max bytes reader takes our response writer, the body, and a number. If you mouse over the inline documentation, you'll notice that it prevents clients from accidentally or maliciously sending a large request and wasting server resources. It takes a response writer because it will return an error for us if the body is too large. In this case, we've set it to 1 megabyte, which should be plenty for our uses. Now we need to unmarshal our JSON again, but in this case, let's actually use a decoder. And we'll give it the request body we just read. We're using a decoder because this has a useful method. Disallow unknown fields. If we mouse over, we can see that the inline documentation tells us that this will cause decoder to return an error if there are fields in the incoming data that don't match our struct. Much like with onMarshal, we need to have a target for the JSON data. Let's just call it U. And here, we'll decode it. Once again, we'll check the error. And once again, we'll hide the details of the error from the consumer, but log them. To the user, we'll give a message that's helpful, but doesn't expose the internals of our service. And don't forget to return here. Once we've done all this validation, we should have a user data object that we can now use. Let's go ahead and use our manager to add them. Remember, we do validation of the user data at the user manager level, so here we just need to check the error. If there is an error here, we can probably return this to the user. Let's go double check. We return a fairly safe and helpful set of strings here, and these are probably okay to show to the user. You will recall that getUserByName actually doesn't return an error currently, but this is the one that I would check to make sure that no sensitive information is disclosed here. We could use a sentinel error and give a more generic response or something like that. For our purposes, I'm happy to return these. And because most of these relate to data validation, let's just return a status bad request. Don't forget to return. And you'll note that we haven't written anything to the body. In this case, we could return the user or something like that, but let's not. Let's just say that it's a successful request. For that, we'll just use write header with status OK. Hey, Editor Mongoose here. I made a mistake when I was recording this. This would actually return a status 200 without writing the header. What we should do here is do status created and then check for that in the test. Make that change, it'll be okay. Now let's run our tests again. And as you can see, everything passes as we expect. But there is another piece of validation that we could do here. If our server had the ability to handle multiple different content types, like say JSON and XML, this would be even more important. For this case, it's not really important, but let's follow best practices anyway, and check and make sure that we do have a content type set, and that it is JSON. And you can see that my IDE is helping me out here. Now that we have the data out of the header, let's just check it. And it should be application/JSON. And here, let's return a meaningful error. We'll say unsupported content type header and echo back what they provided. And we'll return unsupported media type for the response code. Let's run our tests again. And you can see that we failed. Unsupported content type header is empty, which makes sense. We didn't set anything in our request that we generated. If we come over to our test, we just need to once again set the header. Let's run again. Everything seems to be working. Let's go ahead and test this. We'll run our server and pull up our API testing tool. We'll set it to add user. And we know that we need to have the user data struct represented in our JSON. If we send this, oh no, method not allowed. We forgot to hit post. We send this, we got a 200 OK, no body returned. In this case, you can see our content type header has been set. What if we didn't send that? We would get our message back. But we also got an error indicating that a user with this name already exists. We forgot to return. Very important. Let's restart the server. And we'll send this again. Now we only get our message about the content type header. And then if we send this again, we get 200 OK. If we send once more, we get an error that this username already exists. Everything seems to be working very well for us. Let's stop the server and tidy this up. As we just showed, it can be easy to forget a return, and in that case, we actually modified our system even though we returned an error, which is not ideal. There are a number of different strategies for how to handle this, but most of them are kind of beyond the scope of this course. For us, let's just go ahead and add a test that validates that we return the expected status code and the expected body in the case of a bad content type header. Over here, we'll add a new test and we'll call it test add user bad header. In this test, we'll create a request with a nil body. We're not expecting to get beyond content type validation. We will still need a recorder, and we'll still need our test manager and server. Now we'll call our function. Now we'll check our status code. Now, if we were to run this, you'd see that the tests pass. Unfortunately, if we were to comment this out temporarily, you'd see that our test still passes, but we do get an error here. This test is not yet complete. Let's put this back really quick and minimize that. We need to check the body as well. Now let's run our test. And you can see it passes. If we take our return back out again, you can see that it fails, as we expected. Because not only did it get this as the body, it got bad request body, because that was added later. Let's put this back in. And we'll run the entire suite really quick. Everything's working. Let's go ahead and tidy this up. And we'll move on. Now that we have a way to add users, it'd be good to have a way to get users as well. Let's go ahead and set up the handle func for that. For this, we're going to use a post again. It's not technically RESTful to do a post when you're not changing the system, but GET requests shouldn't have a body. This is a topic of great debate among developers, and you should do whatever you think best here, unless your company or existing code says otherwise. Let's hook this up to getUser. And we'll create a method called getUser as well. And we'll add in our temporary error as usual. Now let's add a test for getUser. We'll call it test getUser. As usual, we'll create variables for our test parameters. For this, we'll use a string for the email, because the output of this should be a user data. Now, let's create our test manager and test server. With that set up, we'll need to add the user to the test manager. Here, if we fail, it'll be considered a fatal error to the test. Now, let's create the test query that we're going to use. We're going to use the user data struct. Nothing says that all fields must be filled. If we wanted that behavior, we would need to implement it. For this, we can reuse the same structure and only examine the first and last names. Then, later, if we were to add a way to look up a user by email to the user manager, we'd be able to add that as well. For now, though, let's just create the test query as a user data object with the first and last name populated. Now that we have an object, let's marshal it to JSON. Once again, if we fail to marshal, it'll be a fatal error for the test. Now we can create our request. Let's go ahead and be strict with the content type header in this one as well. We'll create our test recorder, and we'll call our new method. When we get a response back, we'll check the status code. Next, we'll need to decode our response. Let's also be strict here and disallow unknown fields, the same way that we did on the incoming data, just to be sure that the data that we get back never changes without us knowing about it. Now, once again, we'll need a target to decode into, and we'll call decode. An error here will also be considered fatal to the test. Next, let's create the expected data. Lastly, let's use reflect to make sure that they're equal. And we'll build our reader-friendly error the same way we have been. Now let's run this. As we expected, it failed. Let's minimize this. Because we're being strict about our content type headers, let's also add a test to make sure that this does not return data if it doesn't have the correct header. For this, it's going to look very similar to this test, so let's just copy it. We'll place it below. We'll change the name to test get user bad header. We'll change the target, even though this is mostly just documentation. And we'll change the call that we actually make. Now, let's run all the tests. And you'll see that both of these fail, as expected. Let's minimize this again. And we can start implementing this. First things first, let's do our validation of the content type header. And because this is all going to look exactly the same, let's just go ahead and copy it. We can actually reuse almost all of this top. This might be a good candidate for extraction into a function, but for now we'll just copy and paste it. However, we do want to change this to get users. That'll help us if we're reading logs later. Now we can call the user manager's get user by name function. As you might recall, there's two different possibilities for an error here. The first would be our sentinel error. Let's check that now. In the case of a no results found error, let's return a status not found, and the body will just set to no users found. Otherwise, let's use our normal strategy of using slog to give us a log message that we can track down, but also returning an error to the user. For this one, it's hard to give a status message that doesn't expose any internal details, so let's just give it a generic HTTP status internal server error. You'll note we don't have a return yet. We're going to put it here, so they'll execute after our if statement. If we pass that point, that means that we should have a user here, but it'll be a user manager user. We'll need to convert it. Fortunately, we already wrote a function to do that. Now, because we're returning JSON data, we need to marshal this. In this case, we want to do the same strategy. If there is an error, because there's nothing that the user could possibly do to fix this error, and there's nothing that we can tell them about it that would have any meaning for them. So we'll return a generic internal server error, but also log our message for ourselves. If we don't have an error, then we need to write the body. Because we're returning application JSON, let's set our own content header as well. And then we'll write to the body like we did before, ignoring the write count. In this case, we can just give it the marshaled slice of bytes. And once again, if there's an error, we'll do our best to log it for ourselves so we can fix that. With that done, let's run our tests again. And everything's passing. Let's test manually. We'll run our server, and we'll open our API testing tool. Here, we need to add a user so that we can get them back out. 200 OK was received. We'll take out the email, and we'll send a request to get user. And we can see that we got our test user back, including the email. Everything appears to be working. Let's also test looking up a user that doesn't exist. Let's just say we add a 1 to first name. We get a 404 not found, as we expected. But we didn't cover that in our testing. Let's go ahead and add that now. If we minimize this, we know that we're looking for no users found in the body. Let's go ahead and copy this test. And we'll rename it to test get user, no user. We'll still add a user just so that there's somebody in there. But in our query, we'll change the username to something that doesn't exist. That way we know it's checking correctly. Here, we don't expect a status OK anymore. We expect a status not found. We also won't be expecting JSON data, so let's go ahead and delete that. Instead, we'll check our expected body. And don't forget to update this to a quoted string. And we can probably take out this new line for this one. These won't be as long. With that done, let's go ahead and run this again. And everything's still passing. We're still good to go. Also, let's go ahead and stop our server. Left that running. Let's change our handle hello header and the handler for it to do a user lookup instead of just blindly echoing things back. For this, let's change the header keys that we use. We'll use user first and user last. Note that because we don't have any consumers, we can make this change. If you did have consumers, then it wouldn't be a great idea to change the way this API behaves. You might have to put this on a different endpoint or look at API versioning. That's beyond the scope of this course. For us, we have no consumers, we're able to make this change. Also, instead of just hello username with an exclamation point, let's return hello, first name, last name, exclamation point, and then your email is the user's email. Because we're making a lot of changes to this endpoint, let's actually refactor the test first. As a challenge, go ahead and pause the video and do this now. Okay, hopefully you're able to figure that out. This is kind of a bigger task, but that's kind of the point, right? This is still fine. For this, we'll say user first, and it's test. This will be user last, and it's man. We're not changing the username. We will, however, need a test manager now. And we'll need to add the user to it. And we'll say that his email is testman@example.com. If there's an error adding this, it'll be a fatal error for the test. Now we'll need a server. And we'll need to change this to a method call. Obviously, this is not currently a method, but that's okay. We'll still want a status code OK from this, but our expected message will be different. We could build this and use variables like we have before, but for now, this is fine. This wasn't part of the challenge, but hopefully you might have noticed that we'll have to refactor this as well. We don't actually need to have a user manager for this, because we're not going to get that far. We do need the test server though. And this will need to be a method call. Alright, next part of your challenge is to go ahead and refactor handle hello header. We've established the behavior we desire, and it should be easy enough to implement. Go ahead and pause the video and do this now. Alright, hopefully that went well for you. First and foremost, let's go ahead and say that this is now a method. And as part of that, let's move it up here with the others. This is purely for visual organization, and if you don't like that style, you don't need to do it. I will though. Now, this is no longer an invalid username. It's actually going to be an invalid first name, and this will be user first. And let's just copy this block, because we're going to do the same exact thing for the last name. And let's change this as well. Just like so. And make sure that we update the string here for last name. Now, let's see if we can find this user. Just like in get user, we have two possibilities here. Let's just copy this block. Otherwise, we'll have a user. Let's use a format string to build our result. And remember to use address here. Now, we write the response to the body. And it does need to be a slice of bytes. We could have used a byte buffer here once again like we have before, but there's a lot of different parameters here, and it would just be a lot of lines to build it. A format string will work just fine. Once again, if we have an error, we'll log it for ourselves. Also, we need to make sure that we update this handle hello header in the handle func. Now, let's go ahead and run our tests again. Everything is passing except for our no header, which is correct. We forgot to update this string. Let's do that now. Once more, we'll run them, and everything's passing. Because this is the first validated, it's the first error we'll get back. You may actually wish to change the return to have both of these say invalid username provided. That way it'd be easier to check this. But we're really just doing a simple example, so it's fine. Let's minimize this. And let's run our server. And if we pull up our API testing tool, we can use our add user endpoint to insert a test user. And then we can change our endpoint. We'll change it back to Git. And we'll delete this. We'll go to headers. If you have a user in here still, you can just delete that. We'll add user first, which we set to Insomniac. And one more for user last, which we set to tester. We'll send that, and we get our answer back. Note that our body is empty. Everything appears to be working. We can move on to the next section. And that'll wrap up this section. Thank you very much for watching, and I hope you learned something. If you'd like to support me and help me to create more content like this, check the video description below for ways in which you can do that. You can also just share this video with your friends, and that'll help a lot too. Thank you very much again, and we'll see you in the next one.